Welcome to Chapter 5. In this lesson, we're going to be verifying trigonometric identities. So the objective is typically we have a lot of different objectives in a lesson. This one is just one. So we're going to use fundamental trigonometric identities to verify identities. All right, so what does that mean? These are trigonometric identities that we're going to use to be verifying other identities. So essentially what I would do, especially when you start the practice, is print this slide or write have this available to you in hard copy as you go and do any of the practice questions. So all of these are what we're going to be using to do these types of questions. So to verify an identity, so that is the objective. We're using what we saw on the last slide to verify an identity. We show that one side of the identity can be simplified so that it is identical to the other side. Each side of the equation is manipulated independently of the other side of the equation. You start with the side containing the more complicated expression. Okay. So if your goal is to verify this identity up at the first line here, sine of x minus sine x cosine squared x is equal to sine cubed x. What, by definition, what we just looked at is we're going to try to manipulate one of the sides to look like the other side. It was suggesting to manipulate the more complicated side to make it look like the simpler side. So what you're going to do is take the more complicated side, in this case it's the left side, and what we're going to do is manipulate it in a way that will make it look like sine cubed of x. So the first thing we can do is say sine of x minus sine of x cosine squared of x is equal to sine of x times 1 minus cosine squared of x. Essentially what you've done here is a GCF factoring, right? You have sine of x minus sine of x times cosine squared of x, so you factor out a now it's sine of x times 1 minus cosine squared of x. Using the identity, that's sine squared x, and again, this was off of that first slide that we looked at, that I would again have right next to you right now, that has the list of everything you're going to use. The one that you're going to use from that slide to help with this is sine squared of x plus cosine squared of x is equal to 1. So that means sine squared of x is equal to 1 minus cosine squared of x. So you can swap out 1 minus cosine squared of x for sine squared of x. And then sine x times sine squared of x is equal to sine cubed of x. So what you've done is you've proved the left side of the identity is equal to sine cubed of x, which is what the right side is, thus proving that the original identity was true. All right, here's another one. So combining fractional expressions to verify an identity. So in this case, you're starting with sine of x over 1 plus cosine of x plus 1 plus cosine of x over sine of x is equal to 2 cosecant of x. So the first thing you need to do when you have fractions that you're adding, no different than when you learned, remember when fractions were just numbers, you needed a common denominator to add those fractions together. This is no different. Okay, so between fractions that have a denominator of 1 plus cosine of x and sine of x, the least common denominator is sine of x times 1 plus cosine of x. So out of the two fractions, we're going to simplify the left side to try to make it equal to the right side here. The first fraction has a 1 plus cosine of x. So you're going to multiply numerator and denominator by sine of x. And the second fraction has a denominator of sine of x. So we're going to multiply numerator and denominator by 1 plus cosine of x. Okay. Now we're going to actually simplify these two. So this simplifies to this, where, well, we're only simplifying the numerators, okay? Because the denominator we're going to leave as the common denominator. So sine of x times sine of x is sine squared of x. 1 plus cosine of x times 1 plus cosine of x needs to get FOILed. All right, so 1 times 1 is 1. 1 times cosine of x is cosine of x. Cosine of x times 1 is cosine of x. So you've got two of them. So 2 cosine of x. And then cosine of x times cosine of x is cosine squared x. Okay. Now we can combine that all in one fraction. All right, so the left side of the identity is now just this one fraction, because you have the point of getting the common denominator was so that you could add the numerators together. All right, so that's just what's happening in this line here. We're going to regroup it into things that kind of make sense. So sine squared of x plus cosine squared of x is going to go together. And then 1 plus 2 cosine of x is going to go together there. The reason why you're going to do sine squared of x plus cosine squared of x is because one of the identities is sine squared of x plus cosine squared of x is equal to 1. So you can swap out sine squared of x plus cosine squared of x for that one, right? That 1 and that 2 cosine of x was already there. Now 1 plus 1 is 2. Now you've got 2 plus 2 cosine of x as the numerator. The denominator we didn't really touch on this slide at all. And again, we added those to get the 2. Now you can divide out the 1 plus cosine of x, 1 plus cosine of x. They're gone, and you just have 2 sine of x. You know, 2 as a numerator can just be 2 as a coefficient. So now you have 2 times 1 over sine of x. Well, 1 over sine of x is cosecant of x, right? And then 2 cosecant of x is what the right side was. So again, that's your goal, right? Is to take one side, make it look like the other side. So some strategies, because here's the thing, this lesson can be stressful because every question is different. And I guess you could say that about any math, but this is what I mean. There isn't one, I can't give you these 5 steps to follow every time, and then you get the answer. Like think of when we learned how to factor quadratics, and we learned the MUDS method, right? If you followed those 4 steps, you were guaranteed to get it. If you followed those 4 steps properly, you were going to get it right, right? This is not where we're at in your math career, in that you're not going to be given 4 steps, you just follow them, you get the answer without really doing much thought. The process you're in now is you have those list of identities, and you got to use the ones that are going to get you where you need to get. So each question is different. The processes that you're going to go through is different. So it's really just a matter of practicing and getting used to using those identities to help you prove one side or the other. So one of your strategies can be changing sines to cosines, or changing from other identities to sines and cosines. Like if you have a secant, change it into a cosine, that kind of thing. You might need to use some factoring, like in one of the examples we just did, we did a GCF factoring. You might have to use more than one technique. If you have 2 fractions, you probably need to add them or subtract them together. So getting a common denominator is something that most likely you'll need to do if that's what you're presented with. Multiplying by the same factor. All right, so here's another one that we're going to look at. This one's a little more complicated because in the first 2 examples, we just took one side and made it equal to the other side. Sometimes that's not going to be totally feasible. So you're going to have to work with both sides separately to verify the identity. So what does that mean? Well, in this case, we're going to start by working with the left side. So you have 1 over 1 plus sine theta plus 1 over 1 minus sine theta. Well, a good place to start, like we just talked about in that list that we just looked at, if you have two fractions, get a common denominator and add them together. Well, in this case, add them together. For subtraction, you subtract them. The common denominator is just going to be multiplying the two denominators together. So the fraction that is 1 plus sine theta as a denominator needs to get multiplied by 1 minus sine theta. And the fraction that is 1 minus sine theta in the denominator, you're going to multiply by 1 plus sine theta in the denominator. So what you end up with is 1 minus sine theta plus 1 plus sine theta over 1 plus sine theta times 1 minus sine theta, right? The numerator simplifies pretty easily here because negative sine theta and sine theta will add to 0, so the 1 plus 1 just makes 2. Okay, if you FOIL these together, 1 times 1 is 1. 1 times negative sine theta is negative sine theta. Sine theta times 1 is 1. This is sine theta. Those will add to 0. And then sine theta times negative sine theta is negative sine squared theta. So that's how you end up from here to here. And these are just the steps that I just talked you through. All right, now you're going to work with the right side. So we're going to take 2 plus 2 tangent squared theta. All right. So the first thing they did was the first thing from our list on the previous slide, which is if you can work with sine and cosine, do that. Tangent by definition is sine divided by cosine. If it's tangent squared, then it's going to be sine squared theta over cosine squared theta. So you're using, well, essentially you're using this part here. And you're just flipping out the tangent squared theta for sine squared divided by cosine squared. Rewrite each numerator with the least common denominator. So your fractions, well, the 2 is this fraction here, right? The least common denominator between 2 and 2 times sine squared theta over cosine squared theta is cosine squared theta. So we need to multiply numerator and denominator 2 over 1, essentially, by cosine squared theta over cosine squared theta. This fraction didn't change other than you just took the coefficient and made it part of the numerator. Now you can add them together, and you get 2 cosine squared theta plus 2 sine squared theta over cosine squared theta. So factor out the 2, and now you've got 2 times cosine squared theta plus sine squared theta. Then we can use the identity that sine squared theta plus cosine squared theta equals 1. So 2 times that, since it equals 1, is just 2. Then we can use the fact that sine squared theta plus cosine squared theta equals 1. Corollary is that cosine squared theta is equal to 1 minus sine squared theta. So we just flipped out cosine squared theta for 1 minus sine squared theta. Sorry. So what we've essentially done is we took the left side and we worked it and got it equal to 2 over 1 minus sine squared theta. Then we took the right side, we worked it to get it to equal 2 over 1 minus sine squared theta. So we didn't just work with one side. We worked both sides and got them equal to the same thing. Since both sides were equal to the same thing, that means both sides must be equal to each other. So that means the identity is verified because you got both sides to equal the same thing. We're going to do the exit ticket a little different here. There's 2 slides left, so you can either look at the screen here, write them down, whatever, do it that way. Or I always post the notes in the assignment so you can go back and look at that PDF. Both these slides are there. And I say both because there's 2 parts to the exit ticket. What will be different is you're not really going to submit this because there's no way I could make this multiple choice. There's no way I could make this like a free response answer. You're not going to type all this in. mean, I suppose we could have done a Cami type of thing, but I didn't want to get in all that at this point of the year. So here's what we're going to do. I'm going to give you 2 questions. I want you to try them on your own, or 2 identities to prove. You're going to try them on your own. What will be the same is that we will go over it together tomorrow. So with whatever time you have left in class today, I want you to look at this identity. If we had a chance to write it down, and then there's a second one. And again, these are both posted in the notes assignment. The notes that are posted within the assignment. Try both these on your own. See if you can get one side to equal the other. And then we will go over it first thing in class tomorrow. So jump in the breakout room if you have any questions, let me know. Otherwise, just give these a try, and we'll go over it tomorrow.